Everything you think you know about speed is a lie. It's a comfortable, necessary lie that your brain tells you every morning just so you can function without losing your mind. When you flip a light switch in your bedroom, the room is flooded instantly. To your human eyes, to your primitive biological sensors, that light didn't travel. It simply appeared. It was here, and then it was everywhere. This is the foundation of our intuition. We grew up on a planet where the fastest thing in existence feels like magic, a force that transcends time and space. We've spent our entire history believing that light is the ultimate messenger, the bridge that connects us to the rest of reality. But as soon as you step off this tiny, fragile rock and look toward the stars, that intuition doesn't just fail you, it betrays you. It's like trying to navigate the Pacific Ocean using a map of your backyard. The scale of the universe doesn't just break our understanding of speed, it mercilessly crushes it. Because here is the terrifying truth that physicists rarely say out loud, and that most of those viral documentaries you've watched completely ignored. Light is not fast. Light is agonizingly, hopelessly, comically slow. In fact, on a cosmic scale, light is essentially standing still. We are living in a universe that has been carefully designed, or perhaps accidentally constructed, to be a series of isolated planetary prisons. And the speed of light isn't the key to the door. It's the bars of the cage. To understand why aliens will never reach Earth, not tomorrow, not in 1,000 years, not ever, we have to start by dismantling the 1.3-second deception. Look up at the moon tonight. It looks close, doesn't it? Like a silver coin you could almost reach out and touch. When we sent the Apollo astronauts there, they spoke to mission control, and the delay in their voices was barely noticeable. Just a slight conversational pause. That pause was the 1.3 seconds it takes for a radio signal, moving at the speed of light, to bridge the gap between Earth and its only natural satellite. On our human scale, 1.3 seconds feels like nothing. It's the time it takes to take a single breath. This is the first layer of the deception. It tricks us into thinking that the speed of light is our ally, a tool that makes the solar system feel like a neighborhood. But now, turn your gaze toward the sun. It's 93 million miles away. When you step outside and feel the warmth of its rays on your skin, those photons didn't just arrive. They left the surface of the sun 8 minutes and 20 seconds ago. This is where the cracks in the illusion start to show. You aren't looking at the sun as it exists right now. You are looking at a ghost. You are looking 8 minutes into the past. If the sun were to suddenly vanish, if some cosmic entity snuffed it out like a candle, you wouldn't know. You would continue to see it shining in the sky. You would continue to feel its warmth for a full 8 minutes of blissful, terrifying ignorance. For 8 minutes, we would be orbiting a shadow, held in place by the gravity of a star that no longer exists. This delay is the universe's way of whispering a warning to us. It's the first hint that light is a messenger that can't keep up with the scale of the world it inhabits. And as we push further into the void, that whisper becomes a scream. By the time you reach Mars, the delay is 20 minutes. By the time you reach Neptune, it's 4 hours. Voyager 1, the fastest thing we've ever built, has been screaming away from us for nearly 5 decades. Yet it is so far away now that a signal takes nearly a full day to reach us. A single message, moving at the absolute maximum speed allowed by the laws of physics, takes 22 hours just to leave our backyard. And Voyager hasn't even reached the nearest star. It hasn't even completed 1/400th of a single light year. This brings us to the slow light paradox, a concept that the successful outlier videos usually skip in favor of flashy graphics. The paradox is this: the universe provides us with just enough light to tease us, but not enough to ever let us participate. We can see the stars, we can analyze their atmospheres, we can even detect the chemical signatures of alien life on distant worlds. But the same light that brings us that information is what proves we can never go there. It's a cosmic, look but don't touch policy. Current competitors treat the speed of light like a record to be broken, or a hurdle that a sufficiently advanced civilization could eventually clear. They assume that if aliens are a million years ahead of us, they must have found a way. But they are missing the most obscure and terrifying theory hidden in the lore of deep space physics. The idea that the speed of light isn't just a limit, it was designed to be a firewall. Think about the number, 299,792 kilometers per second. Why that number? Why not double it? Why not 10 times faster? In a universe of infinite possibilities, the speed of light seems strangely, specifically tuned to keep civilizations apart. Some fringe theories suggest that this isn't a coincidence. They argue that the speed of light acts as a cosmic safety protocol. If civilizations could travel between stars in a human lifetime, the galaxy would be a chaotic war zone of competing species. By making light slow, the universe ensures that every civilization is forced to evolve in total, safe isolation. It's a firewall of solitude that protects us from the rest of the galaxy, and protects the rest of the galaxy from us. But there is a deeper, more unanswered mystery that the documentaries miss: the psychological stagnation of a slow light universe. Imagine an alien civilization 10 times more advanced than ours. They have mastered the energy of their star. They have built telescopes so powerful they can see the ripples in our oceans from 1,000 light years away. They look at Earth and they see our cities, they see our lights, they see our potential, and then they do the math. They realize that to reach us, they would have to commit their entire species to a journey that spans geological epochs. They realize that even if they launched a ship today at 10% the speed of light, a feat that would require the energy of an entire planet, their descendants wouldn't arrive for 10,000 years. By the time that ship reached Earth, the civilization that sent it might be extinct. The language they spoke would be forgotten. The very reason for the mission would be lost to the mists of time. This is the forever farewell problem. Interstellar travel isn't a vacation. It's a temporal suicide mission. You aren't just leaving your planet, you are leaving your timeline. You are stepping into a future that will never know you. This is why the sky is silent. It's not because aliens don't exist, and it's not because they aren't smart enough to build the ships. It's because they are too smart to try. They have faced the same verdict we are facing, that the universe is not a playground, but a vast, stretching ocean of nothingness, where the speed of light is a crawl, and the expansion of space is a wall. And that leads us to the most overlooked gap in the current lore: the cosmic expansion wall. Most people treat the universe like a static map, where the distance between star A and star B stays the same. But the lore vault reveals a darker reality. Space itself is stretching. Every second, the distance between galaxies is growing. There are parts of the universe that were once visible to us that are now moving away so fast that even a beam of light will never reach them. They are vanishing behind an event horizon of our own isolation. We are living in a universe that is actively pulling itself apart. Even if you could travel at the speed of light, you are in a race against the expansion of space itself. For most of the universe, that's a race you've already lost. The wall is moving faster than the runner. This means that for any alien civilization out there, the window for contact isn't just closing, it's being physically ripped away. So when we ask, where is everybody? The answer isn't a mystery. The answer is written in the agonizing slowness of the very light we use to see. We are like shipwrecked survivors on separate islands, each of us lighting a fire, each of us seeing the smoke from the other island on the horizon, but neither of us capable of building a boat that can survive the crossing. We can see each other's pasts, but we can never share a future. The speed of light is 300,000 kilometers per second. It sounds fast because you've only ever lived in a room. But the moment you look at the stars, you realize that number is a death sentence for any hope of a galactic community. It is the loneliest number in physics. And as we dive deeper into the energy costs, the biological failures, and the energy paradoxes that make this prison even more secure, you will begin to realize that our solitude isn't an accident. It is the fundamental law of our existence. We are alone, not by chance, but by design. And the light that brings us the beauty of the stars is the very thing that ensures we will never touch them. To understand why we are eternally stranded, we have to look past the numbers and confront the crushing reality of the distance itself. We often throw around terms like trillions of miles, as if our brains have any capacity to process them. We talk about the nearest star, Proxima Centauri, being 4.24 light-years away, and it sounds manageable. It sounds like a distance that a more advanced version of us, perhaps a version with better engines and bigger budgets, could eventually bridge. But the math of the universe doesn't care about our ambition. It only cares about the raw, merciless geometry of the void. Let's try to visualize what 25 trillion miles actually means, because that is the length of the shortest possible bridge between our sun and its nearest neighbor. Imagine you decided to sit down and simply count to 25 trillion. If you spoke one number every second, without stopping to eat, sleep, or breathe, you wouldn't finish in a lifetime. You wouldn't finish in 1,000 years. You would need nearly 800,000 years just to reach the end of that sequence. Think about that time frame. 800,000 years ago, anatomically modern humans didn't even exist. Every empire, every war, every discovery, and every language ever spoken in the history of our species fits into a tiny fraction of that time. And yet, that is the scale of the neighborhood gap. This is the heart of the slow light paradox. The universe has given us just enough light to see the stars, but it has denied us the speed necessary to ever touch them. We can point our telescopes at Proxima Centauri b and see a world that is roughly the size of Earth, sitting in the habitable zone of its star. We can see a place where liquid water might pool in alien oceans and where the chemical signatures of life might be dancing in the atmosphere. But the same light that brings us that image is the very thing that proves we are trapped. Light is the ultimate cosmic tease. It acts as the messenger, showing us the beauty of the gallery, but it simultaneously acts as the prison guard, ensuring we never leave the lobby. Current outlier videos often treat the speed of light like a finish line that we just haven't figured out how to cross. They frame it as a technological hurdle. But the deeper lore suggests something far more unsettling. The speed of light is not a goal to be conquered. It is a fundamental law with no exceptions, no priority mechanisms, and no shortcuts. It is a ruler against which all of reality is measured. If light were 1,000 times faster, the galaxy would feel like a connected community. If it were 1,000,000 times faster, we could have lunch on the other side of the Milky Way. But it isn't. It is specifically, agonizingly tuned to 299,792 kilometers per second. Why that specific number? Why is the universal speed limit set at a pace that makes the stars unreachable within a biological lifetime? This is where the obscure theories of the lore vault begin to suggest a designed barrier. Some fringe physicists argue that the speed of light isn't a random constant of nature, but a safety protocol. By making light slow, the universe ensures that civilizations are born, live, and die in total isolation. It's a firewall of solitude that prevents the infection of one species from ever reaching another. It ensures that every island of life evolves independently, protected from the cosmic scale wars or resource stripping that would occur if travel were easy. If you were an alien civilization looking at Earth from just 10 light-years away, a distance so small it's practically invisible on a galactic map, you wouldn't see the world of today. You would see the Earth of a decade ago. If you were 100 light-years away, you would see us as we were in the early 20th century. To the rest of the galaxy, we are always a version of ourselves that no longer exists. This temporal disconnect means that information is always obsolete the moment it arrives. We are shouting into a void that only echoes back the past. Consider the energy required to even attempt to overcome this slowness. To push even a small, car-sized probe to just 10% of light speed, a velocity that would still take 42 years to reach the nearest star, requires energy equivalent to 7,000 Hiroshima-sized atomic bombs. And that's for a machine. For a ship carrying humans, with the shielding required to survive the relativistic sandblasting of space dust, that energy bill escalates until it exceeds the annual output of entire nations. The universe has set a price for admission to the stars that is so high that even civilizations capable of harnessing the power of their entire sun would look at the bill and walk away. This creates a psychological stagnation that we are only just beginning to understand. If a species mathematically proves that the stars are unreachable, they stop looking outward. They turn inward. They build digital utopias, simulated realities, and inward-facing empires where the speed of light doesn't matter because the universe they inhabit is only as large as their own servers. The reason the sky is silent isn't because there's no one out there. It's because everyone out there has realized that the physical universe is a series of isolated cells. They have accepted the verdict of the slow light. We treat light as a symbol of speed and hope. But in the context of the cosmos, light is the measure of our containment. It is the slow, steady drip of a clock that we can never outrun. Every star you see in the sky is a world that is effectively in another universe. They are close enough to dream about, but the math of 25 trillion miles and the 800,000-year count ensures they remain ghosts. We aren't just far away from our neighbors. We are separated by a physical law that has no interest in our curiosity. The speed of light isn't a bridge. It's the silence between us. And as we will see in the next chapter, even if we had all the energy in the galaxy, the very act of moving through this slow light creates a hazard that no ship, no matter how advanced, was ever meant to survive. If the first 2 chapters of this journey taught us that the universe is vast and light is agonizingly slow, then this chapter is here to teach you that the universe is also remarkably stubborn. We often talk about the speed of light as a limit, but in our everyday lives, we're used to limits being things we can eventually bypass with enough money, enough grit, or enough engineering. We broke the sound barrier. We broke the bond of Earth's gravity. Our intuition tells us that impossible is just a temporary state of being, waiting for a smarter version of us to arrive. But when you look at the real physics of interstellar travel, you realize we aren't just dealing with a hurdle. We are dealing with a sand trap, a relativistic, mathematical sand trap that is designed to swallow any civilization that tries to move too fast. To understand why aliens haven't reached Earth, we have to look at the most famous equation in history, E equals mc squared. Most people see that on a t-shirt and think it's just a clever way of saying energy and matter are related. But for a traveler, that equation is a death sentence. It tells us that energy and mass are 2 sides of the same coin. When you try to make an object go faster, you are pouring energy into it. At low speeds, the speeds we understand, like a car on a highway or a jet in the sky, that energy turns almost entirely into velocity. Your car moves faster, and everything feels normal. But as you climb higher up the cosmic ladder, toward the speed of light, the universe starts to play a very cruel trick on you. It stops turning your energy into speed and starts turning it into mass. Think about that for a second. This is the relativistic sand trap. Imagine you're pushing a car down a flat road. At first it's easy. You push, it moves. But as the car speeds up, it starts to get heavier. Not just a little heavier, it starts to become made of lead. Then it becomes as heavy as a building, then a mountain. The faster you push it, the more stuff the universe adds to the car, requiring you to push even harder. But the harder you push, the more mass the car gains. You are trapped in an infinite loop where your effort is being used against you. This isn't a technical limitation of our engines. It is the fundamental structure of space-time. The universe is literally thickening around you, turning your very momentum into a weight that anchors you to the void. By the time you reach 90% of the speed of light, the ship's relativistic mass has more than doubled. At 99.9%, it has increased by a factor of 22. If you were to try and push that ship the final fraction of a percent to reach the speed of light itself, the math is uncompromising. You would need infinite energy. And infinite is a word we use far too casually. It doesn't mean a lot. It doesn't mean the energy of a galaxy. It means more energy than exists in the entire observable universe. It means that if you harvested every star, every black hole, and every atom in every galaxy, you still wouldn't have enough to pay the bill to move one single grain of sand at the speed of light. The wall isn't just high, it's infinite. This brings us to the most provocative theory hidden in the lore vault, the idea that the universe is not a playground, but a prison. In this view, the laws of physics aren't just natural constants, they are enforced boundaries. Most documentaries treat the speed of light like a property of the universe, like the color of the sky. But what if it's a security feature? If you were designing a universe where you wanted to ensure that aggressive, expansionist civilizations could never interact, where you wanted to prevent a galactic infection from spreading from one star to another, you would build exactly the cage we see. You would make the distances trillions of miles wide. You would make the messenger move at a crawl, and then you would add the relativistic sand trap as the final guard. You would ensure that the more energy a species uses to escape their cell, the heavier their chains become. Current outlier videos often skip this prison theory because it sounds too much like science fiction. But look at the evidence. The energy price nature has set for admission to the stars is so unreasonable that it feels almost targeted. Even if an alien civilization is a Type 2 civilization on the Kardashev scale, meaning they have built a Dyson sphere and can harness the total energy output of their parent star, they still can't afford the trip. A Type 2 civilization is a godlike entity by our standards. They have 400 septillion watts of power at their fingertips. They could move planets. They could simulate entire universes. But the moment they try to send a crude vessel, a real ship, with shielding and life support, at a meaningful fraction of light speed, they hit the rationality wall. To accelerate a ship massing millions of kilograms to just 50% of light speed would require energy equivalent to thousands of years of a planet's entire output. And that's just the first half of the trip. Here is the deceleration trap that everyone ignores. If you spend the energy of 1,000 years to speed up, you have to spend that same amount of energy to slow down when you arrive. If you don't, you aren't an explorer. You're just a relativistic bullet that will scream through the target solar system in a few hours and vanish forever into the dark. So the bill doubles, and you have to carry the fuel for that deceleration with you from the start. But fuel has mass, and as we just learned, the more mass you have, the more the universe punishes you as you speed up. This is the tyranny of the rocket equation, combined with the cruelty of relativity. You are carrying fuel to push the fuel that will eventually be used to push you. It is a mathematical spiral that ends in bankruptcy for even the most advanced civilizations. As the lore vault suggests, a Type 2 civilization isn't limited by their technology. They are limited by their sanity. Imagine you are a member of such a civilization. You have a massive stellar bank account. You have achieved utopia at home. Do you really take a significant fraction of your entire star's energy, the literal lifeblood of your people, and throw it into a single ship that will take centuries to reach a planet that might not even be inhabited by the time it gets there? It's like burning down your entire house just to buy a single loaf of bread. It's not that they can't do it in a purely theoretical sense. It's that no rational being would ever sign the check. This is the silent verdict of the energy equation. The universe hasn't just made the stars far away. It has made the cost per mile so high that travel becomes an act of civilizational madness. This is why we don't see Dyson spheres moving across the sky. The most advanced civilizations don't expand outward. They realize that the speed of light is an enforced boundary designed to keep them local. They look at the energy bill, they look at the relativistic mass gain, and they realize the prison is working perfectly. The harder you try to break out, the more the universe pushes back. Every watt of energy you pour into your engines is transformed by the vacuum into more weight, more inertia, and more isolation. We aren't just limited by our engines. We are being actively held back by the very fabric of reality. The relativistic sand trap ensures that even if you have the power of a star in your pocket, you are still just a prisoner staring through the bars of 299,792 kilometers per second. And as we will explore in the next chapter, even if you could somehow pay the energy bill, the very act of moving through that slow light creates a biological hazard so violent that no life form was ever meant to survive it. So far, we have looked at the universe as a series of vast distances and insurmountable energy bills. We've talked about the slow light paradox and the relativistic sand trap as if they were purely mathematical problems, the kind of things a civilization could solve if they just had enough power or a clever enough equation. But even if you could pay the energy bill, even if you had a star in your pocket to fuel your engines, you would still run into a wall that isn't made of numbers. You would run into a wall made of environment. We like to think of space as a vacuum, a clean, empty stage where our ships can glide from star to star in a perfect, frictionless silence. This is the most dangerous misunderstanding in all of science. Because on the scale of the cosmos, the vacuum isn't empty, it is a minefield. When you step out into the interstellar medium, the space between the stars, you aren't entering a void. You are entering a haze of hydrogen atoms, helium, microscopic silicates, and dust grains. On Earth, these things are harmless. A grain of dust is something you wipe off a shelf. A hydrogen atom is a building block of life. But when you travel at relativistic speeds, when you push your ship to just 10% of the speed of light, the very definition of matter changes. At 30,000 kilometers per second, the road isn't just bumpy. It is actively trying to dismantle you. This is the relativistic sandblasting, a hidden hazard that transforms the simplest elements of the universe into the most lethal weapons imaginable. Consider that single grain of dust. Imagine a particle massing just 1 milligram, a speck of rock or ice so small it would be invisible to the naked eye as it floated in the dark. At the speeds we are used to, hitting that grain would do nothing. But at 10% of the speed of light, kinetic energy doesn't just increase, it explodes. The math is merciless. A 1 milligram grain of dust striking your ship at that speed carries the kinetic energy equivalent to roughly 100 kilograms of TNT. 100 kilograms of high explosives, packed into a microscopic speck that you cannot see and cannot avoid. Every centimeter of your ship becomes a target in a cosmic shooting gallery where the bullets are invisible and the impact is equivalent to a bomb blast. This isn't a rare occurrence. The interstellar medium contains roughly one of these invisible mines every 100,000 meters in the denser regions of the galaxy. Over a journey of 25 trillion miles to the nearest star, a ship with even a modest cross-sectional area would encounter thousands, perhaps millions, of these impacts. To survive, you would need armor meters thick, made of materials humans haven't even dreamed of yet. But here is the shielding paradox that the successful outlier videos never mention. To carry that armor, you need more fuel. To move that fuel, you need more energy. And as we already learned, the more mass you add, the harder the universe punishes you. You are trying to build a tank that can survive 1 million bombs, but the heavier you make the tank, the more energy it takes to reach the speed that makes those bombs lethal in the first place. It is a self-defeating loop of engineering. And the dust is only the beginning. Even the empty gas of space becomes a hazard. At relativistic speeds, every single hydrogen atom in the interstellar medium becomes a high-energy particle. Your ship isn't just moving through a vacuum. It is standing in front of a particle accelerator that never turns off. These atoms strike the hull with mega-electron-volt levels of energy, creating a continuous, relentless stream of ionizing radiation. This is the sandblasting at the molecular level. It erodes your hull atom by atom. It displaces atoms within your semiconductors, corrupting your ship's computers and flipping bits in your AI's memory. The ship literally ages centuries in a matter of decades, its very structure degrading under a bombardment of invisible bullets that no shielding can fully deflect. This leads us to the biological verdict, the second half of this hidden wall. Why has nature never written a creature capable of surviving these conditions? Because biology was designed for stability, and the universe is built on radiation. When people imagine interstellar travel, they picture humans in sleek suits or suspended animation pods, waking up refreshed at their destination. But biology is a fragile, delicate dance of chemistry that evolved under the protection of a thick atmosphere and a powerful magnetic field. In deep space, those protections are gone. The high-energy protons and heavy ionizing particles of interstellar space don't just hit you, they slice through you. A single heavy ion, smaller than a molecule, can cut through your DNA like a hot knife through butter. Your body has repair mechanisms, yes, but those mechanisms were designed for the occasional solar flare, not for a decades-long residence inside a particle accelerator. Over the years of the trip, the damage accumulates. Mutations pile up. Cancer erupts in every organ simultaneously. Cells die faster than the body can replace them. Your very genome, the blueprint of who you are, begins to unravel in the dark. And then there is the gentle disintegration of gravity. Evolution wrote our bodies to function in 1G. Without it, the body begins to forget how to be a body. NASA astronauts on the ISS already show alarming changes after just 6 months. Bones lose density at 1 to 2% a month. Muscles atrophy. The heart weakens because it no longer has to fight the pull of the Earth. Now, project that over a 40-year journey to Proxima Centauri. By the time you arrive, your bones would be as brittle as glass, your immune system would be non-existent, and your vision would be failing as bodily fluids press against your optic nerves. We aren't just not designed for space, we are biologically incompatible with the void. Some suggest the answer is generation ships, vessels where a population lives and reproduces over centuries. But this is where biology meets sociology and fails again. To maintain genetic diversity, you need thousands of people. To sustain thousands of people, you need a closed ecosystem that recycles 100% of its air, water, and waste perfectly for 1,000 years. We have never built a system on Earth that can do that for even 2 years without external help. And even if you could solve the plumbing, you cannot solve the cultural drift. By the 3rd generation, the mission is a myth. By the 10th, the people born on that ship are prisoners of a destination they never chose, serving a goal they no longer understand. Human institutions do not last 10,000 years. They fragment, they war, and they collapse. This is the ultimate biological and mechanical verdict. The universe does not want us to leave. It has set the speed of light as a ceiling, energy as a price, and the environment as a lethal enforcement mechanism. Even if you send machines, the AI verdict is just as grim. No robot can self-repair a burned circuit after 1,000 years of cosmic ray bombardment. No material is immortal. Everything ages. Everything decays. Everything in the physical universe is subject to the slow, relentless erosion of entropy. We are planetary creatures. We are the products of an environment that provides atmosphere, gravity, and stability. The slow light paradox and the relativistic sandblasting are the universe's way of ensuring that life stays where it was forged. We look at the stars and see hope, but the physics of the void sees only targets. The 100 kilograms TNT dust grain and the hot knife DNA damage are the firewalls of our isolation. We aren't alone because of a lack of technology. We are alone because the architecture of reality has declared that contact is a suicide mission. We are a civilization of survivors on a small, protected island, looking out at a sea that was never meant to be crossed. And as we move into the next chapter, we will see that even if you could survive the trip, you would arrive in a universe that has already moved on without you. We have spent the last few chapters discussing the universe as if it were a static map, a vast but stationary gallery of stars and galaxies waiting for someone fast enough to cross the gaps. We've looked at the speed of light as a speed limit on a highway, and the distance between stars as a simple matter of a long-duration commute. But this is the final, most devastating deception our intuition plays on us. Because the map isn't stationary, The highway isn't just long, it's stretching. Every second you spend sitting still, and every second you spend traveling, the very fabric of the universe is expanding, pulling the destinations further and further away from you. This is the expansion wall, the vanishing horizon that current documentaries completely ignore. And it is the reason why our isolation isn't just a temporary state of physics. It is a permanent, accelerating tragedy. To understand the expansion wall, you have to throw away everything you think you know about how space works. Most of us imagine space like an empty room, a container that holds things like stars, planets, and people. In this mental model, if the stars move, they are moving through the room. But Einstein and the physicists who followed him realized something that defies every bit of human logic. Space isn't the room. Space is the fabric itself, and that fabric is being stretched from the inside out. Imagine a balloon with dots drawn on it. As you blow air into the balloon, the dots move away from each other, but the dots aren't running across the rubber. The rubber itself is growing between them. This is what is happening to our universe right now. Between us and the next galaxy, new space is being created every single microsecond. This leads us to a mathematical reality that usually makes people's heads spin. The observable universe is 93 billion light-years wide, even though the universe is only 13.8 billion years old. If light is the absolute speed limit, how can the universe be larger than the time light has had to travel? The answer is expansion. While a beam of light was traveling toward us from a distant galaxy, the space behind that light was stretching, and the space in front of it was stretching. By the time that light finally hits our telescopes, the galaxy that sent it is now tens of billions of light years further away than it was when the journey began. We aren't just looking into the past. We are looking at the ghosts of things that have already been pushed beyond our reach. This is the lore vault's most terrifying, unanswered mystery. The realization that we are living in a universe that is actively pulling itself apart. Current outlier videos focus on how hard it is to reach Proxima Centauri, but they miss the grand isolation of the expansion wall. There is a specific point in the distance where the expansion of space becomes so fast that it exceeds the speed of light itself. Now stay with me here, because your intuition is probably screaming that nothing can go faster than light. And that's true. Nothing can move through space faster than light. But space itself? Space can do whatever it wants. Space can expand at any speed it chooses. At a certain distance from Earth, the cumulative effect of all that new space being created between us and a distant galaxy adds up to a velocity greater than 300,000 kilometers per second. This means that if you were to jump into a ship that could somehow travel at 100% the speed of light, violating every law of mass and energy we just discussed, and you pointed it at one of those distant galaxies, you would still never arrive. You would be like a runner on a treadmill that is moving faster than you can sprint. You would look at your destination, you would give it every bit of energy in the universe, and you would watch, helplessly, as that galaxy slowly recedes into the dark, moving away from you forever. This is the tragedy of the vanishing horizon. Most of the universe is already mathematically unreachable. If we were to launch a mission today at the speed of light, we could only ever reach about 3% of the galaxies in our observable bubble. The other 97% are already behind the expansion wall. They are gone. They are effectively in another universe. We can see them. We can see the light they sent millions of years ago. But we are chasing a horizon that has already vanished. We are like shipwrecked survivors watching a ship on the horizon, not realizing that the current is pulling us away faster than we can swim. But it gets deeper. The expansion of the universe isn't just happening. It's accelerating. This was the discovery that won the Nobel Prize and changed our understanding of the cosmic endgame. There is a mysterious force we call dark energy that is acting like a foot on the gas pedal of the universe. Every day the expansion gets a little bit faster. This means the expansion wall is moving closer to us. One by one, the distant galaxies that we can see today will eventually cross that threshold. They will move away so fast that their light will never be able to reach us again. They will blink out of our sky, not because they died, but because the fabric of space has finally disconnected us from them forever. The lore vault posits a haunting storytelling angle here. We are being pushed into deeper solitude. In the very far future, the expansion will have moved every other galaxy beyond our horizon. If humans, or whatever we become, are still around trillions of years from now, they will look up at a sky that is almost entirely black. They won't see the billions of galaxies we see today. They will see only the stars within our own local cluster, which are held together by gravity. They will live in a static universe illusion, never knowing that there was once a vast, crowded cosmos full of billions of other worlds. They will be the ultimate victims of the expansion wall, living in a cell that has been completely sealed off from the rest of reality. Now, apply this to the alien mystery. If we are being pushed into solitude, so is every other civilization. If there is an advanced species in a galaxy a few 100 million light-years away, they are facing the same accelerating wall. They are watching us recede. They are doing the same math we are, realizing that the window of contact isn't just small, it's closing. This adds a layer of urgency and tragedy that the successful transcripts never touch. It's not just that aliens can't reach us because it's hard. It's that they are being physically carried away from us by the very growth of the universe. This is the cosmic firewall in its most absolute form. If the speed of light is the bars of the cage and the energy requirements are the chains, then expansion is the process of moving the cages further apart in an infinite dark warehouse. You can scream, you can shine your lights, you can try to pick the lock, but the warehouse is growing, and the silence is winning. This reframes the designed barrier hypothesis into something even more purposeful. If you wanted to ensure that no two civilizations ever met, you wouldn't just give them a speed limit. You would make the universe itself an active participant in their isolation. You would make the very ground beneath their feet stretch until they were truly, finally, and eternally alone. The tragedy of the expansion wall is that it turns the universe into a series of finite bubbles. We often think of the universe as infinite, and it might be. But for any living being, the universe is only as large as the distance light can travel before expansion wins. We are trapped in a bubble of causality, a small pocket of space where we can still influence things and be influenced by them. Everything outside that bubble is irrelevant. It is non-existent to us. And as the expansion accelerates, our bubble is shrinking. Our world is getting smaller. This is the vanishing horizon that we have to confront when we ask why aliens haven't visited. Maybe they tried. Maybe they launched a ship 1 billion years ago, aiming for a galaxy they saw in their telescopes, only to realize mid-flight that they were chasing a ghost. Maybe they are still out there, in the dark, moving at incredible speeds but still losing ground, watching their home galaxy and their destination galaxy both vanish into the red-shifted distance. When you look at the stars tonight, don't just see them as distant suns. See them as the last few passengers on a ship that is breaking apart. We are all being carried away into a deeper solitude, pushed by a force we don't understand toward a future where the sky is empty and the cage is absolute. The speed of light isn't just slow, it's a losing bet against a universe that is determined to keep its secrets. We aren't just isolated by distance. We are being evicted from the cosmos, one galaxy at a time. And the wall that is moving us away is the one thing that no alien, no matter how advanced, can ever hope to climb. We aren't just alone in the universe. We are being made more alone every second, and there is nothing, absolutely nothing, that anyone can do to stop the horizon from vanishing. Every discussion about the stars eventually hits a wall, and as we've seen, that wall is usually made of distance or energy. We've looked at the 25 trillion mile gap to our nearest neighbor, and the impossible energy bill required to move even a single grain of sand at the speed of light. But there is a final, far more intimate barrier that the high-retention documentaries and flashy science fiction movies almost never talk about. It isn't a physical wall or a lack of fuel. It is the barbed wire wrapped around the very fabric of reality. It is time. Specifically, it is the paradox of what happens to the living, breathing minds inside a ship when they try to outrun the universe. This is the forever farewell paradox, and it is the reason why even a civilization with infinite energy and perfect shielding would still likely choose to stay home. To understand the human cost of the stars, we have to talk about one of the most beautiful and terrifying effects in all of physics: time dilation. Our intuition tells us that time is a constant, a steady, rhythmic ticking that moves at the same pace for everyone, everywhere. But Einstein proved that time is not a ruler, it is a river. And the faster you swim through space, the slower you move downstream through time. This isn't a theory or a philosophical thought experiment. It is a measurable physical reality confirmed by every atomic clock we've ever sent into orbit. When you move at a high fraction of the speed of light, you are literally swimming against the current of time itself. You are moving through space, but you are also time traveling into the future. Imagine an alien civilization, let's call them the Star Seekers, who decide to visit Earth. They are 100 light years away, a mere stone's throw in galactic terms. They've solved the energy problem. They've built a ship that can travel at 99% of the speed of light. From our perspective on Earth, that journey is simple math. It will take them 101 years to arrive. But for the crew inside that ship, the universe has a different plan. Because of time dilation, that 101-year journey doesn't feel like a century. To them, it feels like only 14 years. On the surface, this sounds like the ultimate loophole. It sounds like the universe has finally given us a gift, a way for a biological being to survive a trip across the abyss without dying of old age. The crew eats, they sleep, they study, and in their minds, only 14 years have passed. They arrive at Earth still in the prime of their lives. But then, they look back. This is the moment the forever farewell paradox reveals its teeth. The 14 years the crew experienced were real, but so were the 101 years that passed back on their home world. In the time it took them to cross that gap, their parents are gone, their siblings are gone, their friends, their children, their entire social circle. All of them have been erased by the passage of a century. The civilization they represented, the one that gave them their mission and their identity, has undergone 3 generations of change. The language has drifted. The culture has shifted. The political reasons for the mission have likely been forgotten or replaced by new crises. The crew didn't just leave their planet, they left their timeline. They are temporal refugees, arriving at a destination to find that the home they were supposed to represent no longer exists. They are guests who have arrived a century late for the appointment. This creates a psychological weight that no amount of advanced technology can alleviate. Interstellar travel isn't a vacation. It is a form of social suicide. You are essentially stepping into a one-way time machine that drops you off in a future that has moved on without you. Current transcripts of outlier videos love to talk about the wonder of discovery, but they ignore the stagnation of the best minds. Think about it from the perspective of a rational, highly advanced civilization. Who do you send on such a mission? You send your best scientists, your most resilient explorers, your most brilliant thinkers. You send the 1% of the 1%. But if you send them, you are effectively deleting them from your own society forever. You are taking your greatest assets and flinging them into a temporal sinkhole where they can never contribute to your civilization again. No rational society would commit to a brain drain of this magnitude. Why would you send your brightest minds on a one-way trip into the future when they could stay home and solve the problems of your own world? Why would you invest the energy of a star and the lives of your best people into a mission where the news of their success won't reach you for hundreds, if not thousands, of years? By the time the message, "we have arrived," travels back at the speed of light, The people who launched the ship are dust. The scientists who designed the engines are forgotten names in a database. This leads to a phenomenon the lore vault calls civilizational stress. When a species matures enough to understand the math of the forever farewell, they hit a psychological wall. They realize that the physical universe is designed to keep civilizations separate, not just by miles, but by years. They realize that any attempt to break out of their planetary prison results in a permanent divorce from their own history. The faster they try to go to save time for the travelers, the more time they lose for the society left behind. It is a mathematical trade-off where someone always loses. This is the hidden reason for the Great Silence. It isn't just that it's hard to build the ships, it's that the cost-benefit analysis of interstellar travel is a joke. Imagine if the first European explorers of the 15th century knew that if they sailed for the Americas, they would arrive to find that 500 years had passed in Europe. They wouldn't have sailed. No empire would have funded them. The risk wasn't just the storm or the sea. It was the loss of everything they ever knew. This creates what we might call the inward empire effect. Once an alien civilization realizes that the outward journey is a temporal suicide mission, they stop looking at the stars as destinations. They turn their incredible technology inward. They build digital utopias, simulated universes, and perfect habitats within their own solar system where the speed of light doesn't matter because the distances are small. They realize that it is better to be a god in a local cage than a refugee in a distant future. The weight calculation, or incessant obsolescence, only makes the paradox more cruel. Suppose you decide to ignore the cost and launch your ship today at 10% of light speed. Your best minds are on board, headed for a star 50 light-years away. It will take them 500 years to get there. But 100 years after they leave, your scientists back home discover a new form of propulsion that can reach 20% of light speed. You launch a second ship. This second ship is faster, more efficient, and carries a fresh crew. Because it's twice as fast, it overtakes the first ship mid-flight. The original crew, who sacrificed their families, their friends, and their entire lives to be the first, watches as a newer, shinier ship screams past them in the dark. By the time the first crew arrives at the destination, the descendants of the second crew have already been there for decades. They've built cities. They've claimed the best land. The pioneers arrive to find they are nothing more than obsolete relics, temporal refugees from a forgotten century, arriving at a world that was already conquered by the people who stayed home a little longer. This is the ultimate stagnation trap. You can't launch because you're waiting for better tech, and you can't leave because if you do, you lose your timeline. Every alien civilization in the Milky Way is trapped in this same logic. The speed of light is the ceiling, but time is the barbed wire. It ensures that the messenger and the message are never in the same phase. We are like shipwrecked survivors throwing bottles into the ocean, not realizing that the current is so slow that by the time the bottle reaches the next island, the person who sent it has been dead for centuries. We look at the Great Silence and wonder why they haven't come. We look for ships in our atmosphere and signals in our radio telescopes. But the answer is right there in the clock. They haven't come because the price of the ticket is everything. They haven't come because they are too smart to say forever farewell to their own world just to see ours. The universe has set a price for contact that no rational being is willing to pay. We are alone, not because the stars are far away, but because the time between them is an abyss that swallows everything we value. The light we see from the stars today is a vision of the past, and any attempt to reach those stars is a one-way trip into a future that doesn't want us. This is the final verdict of the forever farewell. We aren't just isolated in space, we are out of sync in time. Every civilization is a brief candle flame burning in a different room of a dark cathedral. We can see the glow of the other candles through the windows, but the hallways are so long that by the time we walk to the next room, our own candle has gone out, and the one we were looking for has already turned to smoke. The speed of light isn't a bridge, it's the silence that ensures we never meet. Imagine for a moment that we are no longer looking at the stars through a telescope. Imagine we are a civilization that has finally, after thousands of years of dreaming, built the great ship. We have mastered the energy of our star. We have solved the shielding problems. And we have a crew of our most brilliant pioneers ready to step into the void. The engines are idling with the power of 1,000 suns. The entire planet is watching. But just as the commander's hand reaches for the ignition, a mathematician in the back of the room clears their throat and asks one simple, devastating question. What if we just wait? This is the incessant obsolescence trap, and it is the silent killer of every interstellar dream. It is a psychological and mathematical sinkhole that prevents civilizations from ever leaving their home systems, not because they lack the power, but because they have too much foresight. In the flashy documentaries that populate our screens, the narrative always follows a linear path. We build a ship, we launch the ship, and we arrive. But real physics doesn't follow a script. Real physics includes the weight calculation, a cold piece of logic that suggests that launching a ship today is almost always a mistake. It is the realization that in a universe where technology advances exponentially but the distances are static, the pioneers of today are destined to become the relics of tomorrow, passed mid-flight by their own grandchildren. To understand the logic of this trap, we have to look at the mismatch between our technological speed and the cosmic speed limit. Think about human history. When Columbus set sail across the Atlantic, he knew it would take months, but he also knew that no one was going to build a faster ocean while he was at sea. The technology of sailing was stable enough that he could be reasonably sure he would be the first to arrive. But in the realm of interstellar travel, the timelines are so vast that the very technology used to launch a mission becomes a fossil before the mission is even halfway to its destination. Let's run the numbers that every advanced alien civilization has inevitably run. Suppose the Starseekers launch a ship toward a system 50 light-years away. They've pushed their current technology to the limit, achieving a speed of 5% of the speed of light. It's an incredible feat, but at that speed, the journey will take 1,000 years. The crew says their forever farewells, steps into the dark, and begins the long crawl across the abyss. Now, back on the home planet, the civilization doesn't just stop. They continue to innovate. They continue to study the laws of physics. 100 years after the first ship left, they have a breakthrough in fusion propulsion or laser sail technology. They build a new ship. This one can travel at 10% of the speed of light. This second ship is twice as fast as the first. It launches a century later, but because of its superior velocity, it doesn't just catch up to the first ship. It screams past it. Imagine being part of that first crew. You have sacrificed everything. You have left your family, your timeline, and your world behind. You are 500 years into your journey, drifting in the silent dark, and suddenly, you see a streak of light on your sensors. A ship, shining with technology you can't even comprehend, overtakes you. They don't even have to stop. They broadcast a quick greeting, a message from a future you will never see, and they disappear into the distance. By the time the first ship arrives at the target planet, the descendants of the second ship have been living there for 400 years. They have built cities. They have established a government. They have paved the roads. The pioneers arrive only to find that they are not heroes, but historical curiosities, refugees from an obsolete era, stepping off a museum piece into a world that has already moved on without them. This is the relic paradox. And once a civilization realizes it is possible, the motivation to be first evaporates. This creates the infinite regress of waiting. If you know that waiting 100 years will cut your travel time in half, you wait. But 100 years later, when the 10% ship is ready, your scientists tell you that if you wait just 50 more years, they might hit 15%. So you wait again, then 20%. Then 25%. You become trapped in a loop of eternal launch delays, always waiting for the final version of the technology, the one that is so fast that no future ship can ever overtake it. But here is the most cruel part of the trap. the one that Richard Feynman's insights and the deep lore of physics make clear. There is no final version that solves the distance. As you wait for better technology, you eventually hit the wall of the speed of light. You might reach 90%, 95%, or even 99.9% of light speed. But as we've seen in the relativistic sand trap, every incremental gain in speed requires an exponential, almost infinite jump in energy. You can wait for 1,000 years for a better engine, but that engine still cannot break the 300,000 kilometer per second ceiling. So, the civilization stays home. They realize that no matter how long they wait, the journey will always be a forever farewell. They realize that the faster they go to try and catch up to the future, the more they are punished by the mass gain and the radiation of the vacuum. The weight calculation doesn't lead to a faster trip. It leads to a realization of futility. It turns the outward gaze of a civilization inward. Why spend the energy of a star to send a ship that will be obsolete mid-flight, when you can use that same energy to build a perfect, simulated universe at home where distance doesn't exist? Current outlier videos often skip this psychological stagnation. They assume that a Type 2 civilization would just keep building bigger and better things, because that's what we do. But they forget that advanced civilizations are, by definition, old. They are stable. They are rational. And a rational civilization doesn't sign a check for a billion-year project that will be overtaken in its first century. They see the incessant obsolescence trap as a law of nature, as fundamental as gravity. This logic also explains why we don't see old probes from aliens in our solar system. If a civilization is 10 million years old, they've had plenty of time to launch ships. But they've also had 10 million years to realize that every ship they launch is a waste of resources. Every probe they could have sent 1,000,000 years ago would be a joke compared to what they could send today, and what they send today will be a joke compared to what they could send in another 1,000 years. This results in eternal stagnation. Every potential interstellar species is waiting for the same thing: a loophole. They are waiting for a way to bypass the speed of light, to find a wormhole, or to master a warp drive that doesn't require the mass of a galaxy to fuel. But as we've explored, the universe doesn't sell the materials for those dreams. It doesn't offer a budget for the impossible. And so, the wait becomes a permanent state of being. Think about the cosmic haystack. We are looking for a needle, but the needles aren't being made because the factory is stuck in a permanent upgrade cycle. Every alien civilization is like a person who never buys a computer because they know a faster one is coming out next month. They spend their entire history in the waiting room of the cosmos. They look at the stars, they calculate the 25 trillion mile gap, they look at their engines, and they decide to wait for the next breakthrough. But the next breakthrough only reveals more distance, more energy requirements, and more obsolescence. This is the deeper, quieter reason for the great silence. It isn't that life is rare, and it isn't that everyone dies in a nuclear war. It's that the math of the universe is so discouraging that it kills the will to explore before the first ship is even built. The speed of light is so slow that it makes every journey a gamble against time, a gamble that no rational species is willing to take. We are all stranded on our separate islands, not because we can't build a raft, but because we know that by the time the raft reaches the next island, we will have forgotten why we wanted to go there in the first place. The incessant obsolescence trap ensures that every civilization becomes an inward empire. They stop trying to bridge the 800,000-year count. They stop trying to pay the infinite energy bill of the relativistic sand trap. They accept the slow light for what it is, a universal curfew. And they stay inside, under the warmth of their own sun, safe in the knowledge that they aren't missing out on anything, because everyone else in the galaxy is stuck in the same waiting room, watching the same stars, and reaching the same conclusion. We are not alone in our solitude. We are part of a galactic community of civilizations that have all, independently, decided to stay home. The universe is a vast, beautiful gallery of eternal launch delays. We've spent the last several chapters discussing the physical walls of our cosmic prison, the energy bills that would bankrupt a star, the relativistic dust that turns a grain of sand into a nuclear bomb, and the stretching fabric of space that pushes the horizon further away every second. But there is a quieter, more insidious barrier that ensures we remain in solitary confinement. It isn't made of mass or energy. It is made of information. Specifically, it is the realization that in a universe this large, we are effectively invisible. Even if an alien civilization had the technology to reach us, they wouldn't, because from their perspective, there is nothing here worth the trip. To understand this, we have to look at the information bubble that humanity has been blowing into the vacuum for the last century. In 1895, Guglielmo Marconi sent the first wireless signal across a room. Since that moment, humanity has been leaking radio waves, television broadcasts, and radar pings into the cosmos. These signals travel at the speed of light, moving outward in an ever-expanding sphere. As of today, that radio bubble has a radius of roughly 120 light-years. To us, a century of broadcasting feels like an eternity. It encompasses our entire modern history, from the first crackling voices to the digital roar of the internet. We feel like we've been shouting at the top of our lungs for a very long time. But now, look at the map. The Milky Way galaxy is at least 100,000 light-years across. If you were to draw our 120 light-year bubble on a standard map of the galaxy, it wouldn't even be a dot. It would be a microscopic speck, representing roughly 1,000th of the galaxy's diameter. In terms of volume, our presence in the Milky Way is essentially zero. To 99.99% of the stars in our own galaxy, Earth is a silent, dark rock. The signals haven't arrived yet. We aren't just waiting for a reply. We are waiting for the neighbors to even hear the first hello. We are a whisper in a thunderstorm, and the storm is 100,000 light-years wide. This creates the silence of the haystack. Most people imagine the search for extraterrestrial intelligence as a search for a needle in a haystack. But as the deep lore of the lore vault suggests, it's much worse than that. You aren't just looking for a needle. You are looking for a needle that only exists for a single millisecond, on a frequency you haven't tuned to yet, in a haystack the size of a continent. For a civilization to detect us, they have to be looking exactly at our tiny dot, at the exact moment our faint radio leakage passes their planet, using technology that can distinguish a flickering TV broadcast from the titanic roar of our sun. The probability is so low it borders on the miraculous. But let's assume for a moment that there is a civilization out there that can see us. Let's imagine a species located 1,000 light-years away, a distance that is still considered local in a galaxy this size. They have telescopes we can't even dream of. They can resolve the surface of a planet from across the void. They point their lens toward the sun, and they look at Earth. What do they see? They don't see our cities. They don't see our satellites. They don't see the internet or the flicker of our neon lights. Because light takes 1,000 years to reach them, they are looking at Earth as it existed in the year 1024. They see a world of medieval villages and horse-drawn plows. They see the Song dynasty in China and the Viking Age drawing to a close in Europe. They see a planet of pristine forests and smoke from wood fires. To them, Earth is a primitive, low-tech wilderness. Now ask yourself the question of the energy bill we discussed in Chapter 3. If you are a Type 2 civilization with the power of a star, would you spend stellar-level resources, the kind of energy that could power your entire world for 1,000,000 years, to launch a 10,000-year mission to visit a medieval village? Would you commit your species to a temporal suicide mission to say hello to a group of people who are still trying to figure out how to forge steel? The answer is a cold, rational no. To an advanced alien civilization, Earth looks like a boring, undeveloped backwater. Why cross 25 trillion miles to look at a forest? Why risk the relativistic sandblasting of interstellar space for a world that shows no signs of being a peer? Information is the currency of the universe, and our currency hasn't reached them yet. To any alien more than 120 light-years away, we haven't even invented the wheel. This is the information disconnect. Because light is the messenger and the messenger is slow, every civilization is looking into the past of every other civilization. We are all ships passing in the night, but the night is so long that by the time we see the other ship's lantern, that ship has already sunk. If we detect a signal from a star 5,000 light-years away today, we are hearing from a civilization that might have collapsed during the Bronze Age. If they hear us 5,000 years from now, they will be hearing from a version of humanity that might be extinct. This creates a tragedy of asynchronous existence. For two civilizations to meet, they don't just have to exist in the same galaxy. They have to exist in the same narrow window of technological readiness at the exact same time. And they have to be close enough that their information hasn't become obsolete by the time it arrives. The math of the 13-billion-year-old galaxy suggests this overlap is nearly impossible. Civilizations are like brief candle flames burning in separate rooms of a dark cathedral. By the time the light from one candle reaches the next room, the first candle has already burned down to the wick. The information bubble isn't just a limit on our reach, it's a limit on our relevance. We imagine ourselves as the center of a grand cosmic drama, but the slow light dictates that we are actually a non-event. We are a silent rock that has only just started to murmur in a corner of the galaxy. To the rest of the 400 billion stars, the age of humanity hasn't even begun. The light from our first radio towers hasn't even reached the next spiral arm. And then there is the problem of the cosmic haystack itself. Even within our 120 light-year bubble, why is it so quiet? If there are thousands of Earth-like planets nearby, why haven't we heard a single hello? This is where the Lore Vault's techno-signature gap comes in. We are looking for radio waves because that's what we use. But radio is a primitive, noisy technology. We've already started moving toward fiber optics and focused lasers, technologies that don't leak into space. It is entirely possible that a civilization's radio window, the period during which they are loud enough to be heard from the stars, only lasts a few hundred years before they become silent again, moving toward more efficient, focused communication. If every civilization only shouts for 200 years out of their 10,000-year history, the chances of two radio bubbles overlapping is practically zero. We are like two people trying to catch a specific firefly in a forest at midnight. If the firefly only blinks for a second, you will never see it. This leads to the most chilling realization of the information bubble. We might be surrounded by life, but it is life that has already moved past us. Advanced aliens might be communicating using quantum entanglement or gravitons, methods that the laws of physics allow but our primitive sensors can't even detect. To them, our radio signals aren't an invitation. They are technological noise, like the static of a lightning storm. They wouldn't come to Earth for the same reason you don't go into the woods to talk to a cricket. You know the cricket is there, you can hear its noise, but there is no basis for a conversation. The silence of the haystack isn't an accident. It is a product of the slow light and the obsolescence trap working together. Every civilization is trapped in a bubble of their own time. We are looking at a Stone Age galaxy, while the galaxy, if it's looking at all, is looking at a Stone Age Earth. We are all staring at ghosts. When you ask, where is everybody? The answer is simple. They are in the past. Or they are in a future we can't see yet. But they aren't here, in this moment, in this sliver of 120 light years. The speed of light has ensured that the present is a local luxury. In the cosmos, there is no now. There is only here and then. And as long as light continues to crawl across the void at its agonizingly slow pace, we will continue to live in an information desert, surrounded by 400 billion stars that see us as nothing more than a pristine, uninhabited wilderness. The information bubble is the final seal on our prison door. It ensures that even if the physical barriers could be broken, the psychological and rational barriers would remain. Aliens will never reach Earth because they don't know we are Earth yet. They see a forest. They see a medieval village. They see a world that isn't worth the energy of a star to visit. We are alone because the messenger is too slow to tell the universe that we finally arrived. And by the time the message gets there, we might already be gone. We have spent hours dismantling the mechanics of our isolation, We have looked at the staggering energy requirements that would bankrupt a star, the relativistic dust that turns a grain of sand into a nuclear warhead, and the stretching fabric of space that creates a vanishing horizon we can never catch. We've treated the speed of light as a mathematical wall, a frustrating constant of nature that simply is. But now, we have to step out of the equations and into the most obscure and terrifying question of all. What if this isn't an accident? What if the speed of light was specifically, agonizingly tuned to keep us apart? This is the grand design hypothesis, the most provocative idea hidden in the deep lore of cosmic physics. The theory that the speed of light is not just a limit, but a cosmic firewall designed to ensure that every island of life evolves in total, safe isolation. To understand this, we have to look at the number itself, 299,792 kilometers per second. In a universe of infinite mathematical possibilities, why that specific number? Why is it fast enough to let us see the stars and dream of them, but just slow enough to ensure we can never reach them within a biological lifetime? Our intuition tells us the universe is a playground, but when that intuition is crushed by the reality of physics, we are forced to see the universe as it really is, a structure of enforced boundaries. If the speed of light were just a few orders of magnitude faster, the forever farewell would vanish. A civilization could colonize an entire spiral arm of the galaxy in a single generation. If it were significantly slower, the information bubble would never form, and we would live in a universe of literal darkness, unable to see beyond our own atmosphere. The speed of light is tuned to a Goldilocks zone of isolation. It provides enough light to tease us with the existence of others, but enough distance to keep those others from ever touching us. This leads us to the cosmic firewall theory. Many thinkers have proposed the dark forest hypothesis, the idea that the galaxy is full of aggressive, predatory civilizations hiding in the shadows, and that announcing our presence is an invitation to destruction. But the lore vault suggests a more benevolent, if lonelier, interpretation. Perhaps the designed barrier is the only thing preventing the dark forest from becoming a reality. By setting the speed of light at this specific crawl, the universe ensures that no matter how aggressive or expansionist a species becomes, they can never become a galactic infection. They are physically prevented from ever reaching another star system to conquer, consume, or destroy it. The laws of physics act as a universal safety protocol, a mandatory sanctuary of solitude that protects every primitive civilization from the predations of those more advanced. Imagine a universe where interstellar travel was as easy as a cross-continental flight. In such a universe, the oldest and most aggressive civilization would have consumed the entire galaxy billions of years ago. There would be no room for new life to emerge, no time for a species like ours to evolve in the quiet suburbs of a spiral arm. We only exist because the speed of light has kept the neighbors away. We are like a protected nature reserve, and the 25 trillion-mile gap to Proxima Centauri is the high-voltage fence that ensures we are left alone to grow. This is the designed barrier at work. It trades the wonder of contact for the certainty of survival. Current outlier videos often frame the speed of light as a prison wall, a tragedy of physics that we should mourn. But when you look at it through the lens of the grand design, the wall becomes a masterpiece of engineering. If energy were free and light were infinite, the universe would be a chaotic, unstable mess of colliding causality. The relativistic sand trap and the energy verdict aren't bugs in the system. They are the security features that keep the stars shining steadily for billions of years. They provide the stability that life requires to transition from simple chemistry into complex consciousness. The universe isn't preventing us from meeting aliens because it is cruel. It is operating in the only way that life can emerge in the first place. This reinterprets the Great Silence not as a mystery of extinction, but as a victory of design. Every civilization eventually hits the weight calculation and the forever farewell, realizing that the cost of leaving their cell is their own history and identity. They see the information bubble and realize they are invisible. They look at the expansion wall and see the horizon vanishing. A rational, advanced species doesn't see these as obstacles to be overcome. They see them as the closing of a door they were never meant to walk through. They accept their place as an island of consciousness, a localized spark in a vast, dark ocean that was never meant to be crossed. There is a profound beauty in this isolation. It means that the universe is not a singular monolithic empire, but a symphony of solitary sparks. Every star you see in the sky is its own experiment in evolution, its own unique story that will never be contaminated by the influence of another. The speed of light ensures that every island of life is precious and unique. If we could reach the stars easily, they would lose their wonder. They would just be more territory to map and manage. But because of the designed barrier, the stars remain eternal mysteries, visions of the past that we can only ever dream of touching. The lore vault posits that the designed barrier might even be a test of civilizational maturity. A primitive species rails against the cage, trying to find a loophole in the energy equations or dreaming of magic, warp drives that violate the structure of space-time. But a mature species, a Type 2 or Type 3 civilization, understands that the laws of physics are honest. They recognize that the slow light is what makes their existence possible, and they stop trying to be the infection that spreads across the galaxy. They turn their gaze inward, building digital utopias or perfect societies within their own solar system, accepting that the universe has placed them in a sanctuary of silence for a reason. This realization changes how we should feel about our place in the cosmos. We aren't abandoned in a silent haystack, and we aren't failures because we haven't reached the stars. We are exactly where we are supposed to be. We are a localization of the universe's attempt to understand itself, protected by a firewall of light years that ensures our story is our own. The speed of light is 300,000 kilometers per second, not because nature is lazy, but because that is the exact speed required to maintain a universe of clear causal structure, where the past creates the present, and the present creates a future we can control. When we ask, "Where is everybody?" the answer provided by the grand design is that they are safe. They are in their own rooms, behind their own firewalls, living their own unique versions of the cosmic dream. The silence of the universe is the sound of billions of civilizations being protected from one another. It is the silence of a library where every book is allowed to be its own story, without another book rewriting its pages. The slow light isn't a prison guard, it is the ultimate librarian, ensuring that the collection remains diverse, stable, and beautiful. We often fear the idea that we are alone, but the lore vault suggests the opposite. We should fear a universe where we aren't isolated. In a connected universe, we would be a rounding error in someone else's empire. In a slow light universe, we are the sole bearer of consciousness in our own observable bubble, which makes our existence infinitely more precious. The barrier wasn't designed to keep us in, it was designed to keep the rest of the universe out, giving us the time and space to become whatever we choose to be. The speed of light is the loneliest number in physics, but it is also the most compassionate. It is the grand design that tells us we are safe, we are unique, and we belong exactly where we are. We don't need to find aliens to make the universe wondrous. The very laws that prevent us from meeting them are what create the wonder in the first place. We are part of a consistent, logical, and proud universe that operates by principles we are finally smart enough to read. And in that understanding, we find the deepest lore of all. The barrier is the gift. As we move toward the final verdict of this journey, we have to confront the reality that the outward empire is a myth of our childhood. Every alien civilization, if they exist, has faced this same designed barrier. They have all looked at the 800,000-year count and the relativistic sand trap, and they have all realized that the inward journey is the only one that actually matters. We aren't alone because we are rare. We are alone because the universe was built to ensure that every story has its own stage. And as the expansion wall continues to push the galaxies away, Our stage is getting quieter, smaller, and more perfect. The firewall is working, the sanctuary is secure, and the silence of the haystack is the only evidence we ever needed to know that the grand design is complete. We have reached the end of the map. We have explored the geometry of our cage, measured the thickness of the bars, and calculated the impossible energy required to even rattle the door. We've looked at the relativistic sand trap that turns your momentum into lead, the expansion wall that pushes the horizon away faster than you can chase it, and the forever farewell that erases your history the moment you step into the dark. If you followed this journey through the 9 preceding chapters, the conclusion seems inescapable. The outward journey, the dream of a galactic community, of physical meetings between starfaring species, of a future where we step off this rock and shake hands with the residents of a distant world, is a physical impossibility. It is the most painful realization a curious species can face. We were born with the urge to wander, to see what is over the next hill, to cross the next ocean. But the universe has responded with a cold, mathematical no. The speed of light is not a goal. It is the absolute ceiling. The energy required is not a challenge. It is a bankruptcy. The time required is not a delay. It is a death sentence. So, the question we must ask ourselves in this final verdict is simple, yet devastating. If the outward journey is impossible, what is left? If the stars are forever out of reach, what is the purpose of a civilization that has the intelligence to see them, but not the speed to touch them? The answer is found in a transition that every advanced civilization in the history of the cosmos has likely already made. It is the pivot from the outward journey to the inward empire. We have spent our history looking for others out there, assuming that progress means expansion. We assume that a Type 2 or Type 3 civilization would be defined by the number of star systems it has conquered. But as we've seen in the energy and motivation paradoxes, that is a primitive, human-centric way of thinking. A truly advanced civilization doesn't waste the energy of a star on a 10,000-year suicide mission to a medieval village. They don't send their best minds into the temporal sinkhole of interstellar travel. Instead, they do the one thing that the laws of physics actually allow for. They transcend the physical. This is the theory of the digital utopia. Imagine a civilization just a few thousand years ahead of us. They have mastered the energy of their star, but they have also mastered the science of consciousness. They have realized that biological bodies are the primary bottleneck of existence. They are fragile, they require gravity, they are shredded by radiation, and they are confined to a single, narrow environment. So, they leave the biology behind. They upload their consciousness into digital substrates, silicon, light, or quantum frameworks that are millions of times more efficient and durable than carbon-based cells. Once a civilization becomes digital, the slow light paradox vanishes. In a simulated universe powered by the energy of a Dyson swarm, the speed of light is just a parameter in the code. You can travel from one end of your universe to the other in a millisecond. You can experience 1,000 years of subjective history in a single afternoon. You can build worlds that are more beautiful, more complex, and more meaningful than anything the harsh, radioactive vacuum of space could ever offer. While we are out here struggling to send a paperclip-sized probe to the nearest star at 20% of light speed, they are living as gods in an inward empire where they have absolute control over time, space, and reality. This is why the sky is silent. It isn't because they are dead, and it isn't because they are hiding. It's because they have found something better. Why would you spend 10,000 years traveling through a cold, empty void just to look at a forest on Earth, when you can simulate an infinite number of forests, each more vivid than the last, in the comfort of your own star system? Interstellar travel is a money-losing investment that no rational civilization signs the check for. The inward journey is the natural conclusion of the evolution of intelligence. It is the moment a species realizes that the universe has provided them with a star-sized battery and a prison of distance, and they decide to use that battery to build a heaven within the prison. This reframes the great silence from a tragedy of isolation into a sanctuary of stability. We often feel abandoned when we look at the stars and hear nothing but static. We feel like the universe is a vast, empty haystack, and we are a needle that will never be found. But the final verdict of physics tells us that we are not abandoned. We are simply part of a universe that values stability over contact. Contact is dangerous. Contact leads to the infection of one ideology or one species over another. Contact creates causal paradoxes and energy crises. The speed of light is the firewall that ensures every civilization is allowed to develop its own unique story without interference. It is the designed barrier that protects us from the rest of the galaxy and protects the galaxy from us. The universe isn't preventing us from meeting aliens because it is cruel. It is operating in the only way that life can emerge and remain stable. If the speed of light were infinite, the oldest, most aggressive civilization would have consumed the entire galaxy before we even crawled out of the oceans. We only exist because the walls are high and the messenger is slow. Our solitude is the gift that allowed us to become human. Every star you see in the sky is a sovereign island, a solitary spark in a dark ocean. Each one a different room in a magnificent cathedral where the hallways are too long for the guests to ever meet. And that is exactly as it should be. It ensures that the music in our room is ours, and the music in their room is theirs. We must stop thinking of ourselves as trapped, and start thinking of ourselves as protected. We are the masters of our own information bubble. We are the sole bearers of consciousness in our own observable horizon. That makes our existence not a rounding error, but a miracle of localized complexity. The inward empire is not a retreat. It is the ultimate expression of maturity. It is a civilization saying, "We have seen the limits of the physical world, and we choose to create something better." The speed of light is 299,792 kilometers per second. It is a number that has been written into the foundations of reality since the moment of the Big Bang, 13.8 billion years ago. It is the ruler, the ceiling, and the cage. But it is also the mirror. It reflects back to us the truth that our future is not in the stars, but in ourselves. We aren't going to find the answers in a ship. We are going to find them in the code of our own minds and the stability of our own world. When you look up at the night sky for the last time after this journey, don't feel sad about the 25 trillion mile gap. Don't feel frustrated by the 800,000-year count. Smile at the stars, because they are the anchors of a universe that is honest, consistent, and proud. They are the markers of a reality that values the independence of every living thing. We are alone, yes, but in that solitude, we are free. We are a part of a grand design that has given us a small, perfect stage and told us to write our own play. The outward journey is over. The inward journey has just begun. We are star stuff that has become conscious, and we are finally smart enough to realize that the cage isn't there to keep us in. It's there to make sure that the fire we've started here never goes out. We are not alone because we were forgotten. We are alone because we were meant to be unique. And in a universe this vast and this slow, that is the only verdict that truly matters. The haystack is infinite, the needle is precious, and the silence is beautiful.